Welcome to Invertase Hero, Lineweaver Burk Plot Explained. I'm Amjad Muammar for BIOL 3130. Today, we'll meet an enzyme named invertase, see why curvy enzyme plots can be confusing, and use the Lineweaver Burk plot to read two key numbers fast, Vmax and Km. Here's the classic Michaelis Menten curve, rate on the y-axis and substrate concentration, S, on the x-axis. The curve rises and then flattens near Vmax. That flat top makes it hard to pinpoint exact values, like the kilometer, which is the substrate level at half of Vmax. Great picture, tricky measurements. Say hi to invertase, the enzyme that splits sucrose into glucose and fructose. Like other enzymes, invertase speeds up as we add more substrate, then approaches its top speed, Vmax. We'll use invertase as our running example. Imagine the curvy road of the Michaelis-Menten graph. If we straighten that road, it's easier to measure distances. That's exactly what the Lineweaver Burk plot does. We plot 1v versus 1s. Taking reciprocals turns the curve into a straight line. Reading this line is quick. The y-intercept equals 1 Vmax, so flip it to get Vmax. The x-intercept equals -1 per kilometer, so make it positive and flip to get kilometer. The slope is kilometer Vmax. With one straight line, we can read both constants. Let's calculate using invertase. If the y-intercept is 0.010, then Vmax equals 1 divided by 0.010 equals 100. If the x-intercept is -0.200, then kilometer equals -1 minus 0.200 equals 5 mm. One plot, two values, fast and clear. We use the Lineweaver Burk plot to estimate Vmax and Km, compare conditions or enzyme batches, visualize inhibitor effects, and do quick checks in labs and classes. It's simple and very teachable. Now, inhibitors. In competitive inhibition, the inhibitor competes with the substrate for the active site. On the LB plot, Vmax stays the same, the y-intercept doesn't move, but the x-intercept shifts towards 0, meaning kilometer increases. The line gets steeper. In non-competitive inhibition, the inhibitor binds somewhere else and reduces overall catalytic power. On the LB plot, kilometer stays the same, the x-intercept doesn't move, but the y-intercept rises, so Vmax decreases. Again, the line becomes steeper. Okay, your turn. On this slide we'll build a Lineweaver Burk plot from a tiny dataset and read Vmax and Km ourselves. Beat, here are three measurements for invertase at different substrate levels, S equals 2, 5, 10 mm with reaction rates V equals 28.6, 50.0, 66.7 units per minute. Step 1, convert each point to 1 S and 1 V. Step 2, plot 1 V on the y-axis against 1 S on the x-axis. Step 3, draw a best fit straight line, then read the intercepts. Hints, the y-intercept equals 1 Vmax, so you'll flip it to get Vmax. The x-intercept equals -1 km, so take the positive of that value and flip to get km. Pause the video here while you do the calculation. Ready for the answer, beep. The line crosses the y-axis at 0.010, that's 1 Vmax, so Vmax equals 100 units per minute. It hits the x-axis at -0.200 mm, that's -1 km, so km equals 5 mm. If your numbers are close, you nailed it. Small differences come from drawing the best fit line. Invertase showed us the problem. The Michaelis-Menten curve flattens, so precise values are hard to read. The Lineweaver Burk plot straightens the curve, plot 1 V versus 1 S, so the y-intercept gives 1 Vmax, the x-intercept gives -1 per kilometer, and the slope is kilometer Vmax. With one straight line, we can calculate Vmax and Km, compare conditions, and spot inhibitor patterns. Competitive, Vmax same, kilometer increases, and non-competitive, kilometer same, Vmax decreases. Thanks for watching. Now try the practice slide again and read your own constants like a pro.